Hello and welcome back to this course, covering the exam topics for the JNCIS ENT certification. In this section of the course, we're reviewing ISIS concepts, configuration, and monitoring in Junos. In this lesson, we'll be reviewing multi-level and multi-area ISIS. See, being a link state protocol, ISIS will run into the same scaling issues as OSPF. Since all routers within a particular area are required to maintain an identical LSDB, a sufficiently large area with lots of routers and destinations within may cause undesirable effects on some of the lower powered devices participating in the area. Like OSPF, ISIS was designed with the concept of areas, which are a delineation between linked state databases, where only the routers within a particular area must maintain the LSDB for that area. A concept in ISIS, however, which does not have an equivalent relation in OSPF, is the implementation of levels. In this lesson, we'll take a look at the purpose of ISIS router levels and discuss some of the characteristics of areas in the protocol. So, let's jump on in. Only two levels exist in ISIS, Level 1 and Level 2, which are often written in documentation as L1 and L2. The concept of levels is intended to solidify the hierarchical architecture of ISIS, where OSPF performs this with the requirement of having the backbone area 0 connected to all other areas directly. ISIS performs this with the requirement of Level 2 adjacencies to cross area boundaries. As we see here, Level 1 routers will not form an adjacency with a Level 2 router, and vice versa. Level 1 adjacencies cannot cross area boundaries, and although Level 2 adjacencies can cross area boundaries, they are not required to do so. A router can also function as both a Level 1 and Level 2 router. As we'll see in a later lesson, each interface on an IS can be configured to originate either L1, L2, or both L1 and L2 IIH PDUs. There is no requirement for a particular backbone area. However, the intended architecture of ISIS at scale is to have a backbone area of only Level 2 routers, which interconnects all of the other areas with Level 1 routers. This is still not required. We could simply add additional areas by having L1/L2 routers interconnect areas of Level 1 routers, without having any Level 2 exclusive routers at all. Because there's no particular backbone area requirement, though, one could even potentially have an ISIS domain with multiple backbone areas present, with Level 2 only routers. As we mentioned before, the technical reasoning to use multi-area ISIS is to limit the size of the LSDB. Additionally, multiple areas could limit the impact of flapping links or misbehaving devices, since the LSDB updates will not necessarily be flooded to all devices. A very important characteristic of multi-level ISIS is that no LSPs flood from L2 to L1 routers by default. This is a very different function from OSPF and should be noted. Each L1 router, however, will generate its own default route towards the closest L2 attached router. In this way, by default, areas in ISIS function much like an OSPF total stub area. For any specific routes to be propagated from L2 routers to L1 routers, they must be configured explicitly. Now, when we say that each router will generate a default route to the nearest L2 attached router, how might it do this? Let's take a look at this in the following slide. Depending on whether a router is a level 1 or level 2, or both L1 and L2 router, the format of the link state PDUs it originates will differ slightly. As we saw in a previous lesson, the LSP has a 4-bit field for the attached bits, shown in this diagram as ATT at the bottom. Each of the bits are a flag. If any one of them are set to 1, then the originating router is signaling that it is a level 2 attached router. The flag that is set among the 4 bits represents the type of metric that should be used for calculating the cost to that level 2 attached router. When a level 1 router receives an LSP with the ATT bit set, it will generate a default route towards the originating router of the LSP and set the metric cost of the default route according to the metric type indicated in the ATT flag. This is an important differentiation between ISIS and OSPF, where each ISIS router will generate its own default route towards the nearest level 2 attached router. Finally, let's take a closer look at LSP flooding behaviors across areas in the next slide. As we mentioned before, no L2 LSPs will be flooded to L1 areas by default. As you might imagine, using the metrically closest L2 router for all traffic destined for subnets outside the local area may cause significantly suboptimal routing. In this circumstance, route leaking may be configured to leak certain routes from L2 to L1 to allow more efficient routing to specific destinations. Level 2 adjacencies, however, will always receive level 1 LSPs. This reaffirms the concept of the level 2 routers being backbone routers, as they maintain an LSDB which contains all LSPs for all level 1 areas by default. I appreciate you reviewing multi-level and multi-area ISIS with me. I hope that this lesson has been informative for you, and I would like to thank you for viewing.